Welcome, I'm Ryan Hoger, and today we're talking a little bit about indoor air quality in your commercial building spaces. So indoor air quality is kind of a really broad term. We're gonna try to hone in on some specific things that you can think about and even some stuff that you could possibly measure to help determine the quality of your building. And then obviously solving that with better filtration, air purifiers, better ventilation air. Those are gonna be, additional discussions. But let's right now just talk about what it means and how we can measure some of that stuff in a particular occupied space. Let's go ahead and get started. One of the biggest indoor air quality problems in a building is related to moisture. It could mean mold growth, because obviously to grow mold in a building, moisture is one of the things you have to have. It could be something like a leaky ceiling or a pipe leaking behind a wall, a roof leaking. And you can, sometimes that stuff is really easy to see. It's visual damage on the ceiling tiles and the walls. But other times things are happening behind the scenes and you don't know they're necessarily there. And sometimes the moisture isn't coming from a leaky roof or a broken pipe. Sometimes it's just coming from the air in general. So if the space is not being air conditioned very well, the humidity will be higher and hence more potential for bad things to happen in the building. So one of the things you can measure easily in a space is the moisture. There's a couple different ways you can look at that. So I have my handheld probe here. There's all kinds of different versions and models of these types of things. This one here happens to be showing me currently percent relative humidity and temperature. So it's 76 degrees in here right now, and it's 46% humidity, which is fairly low, and that's great. When you start getting above 60%, that's when a little trigger in your head should say, hey, there could be a problem. There's a couple different ASHRAE standards that reference maximum humidity in spaces. One is for human comfort, 60% maximum. The other one's for indoor air quality, 65% maximum. So you don't want to get above 65%. It's really common for that to happen in buildings because of numerous reasons: oversized equipment, leaky building envelopes, all kinds of things. But right now, let's just try to measure it in your space. So I got temperature and I got relative humidity there. The other thing to think about on some of these tools is if I toggle between here, I can scroll down here and I can read dew points, 55 degrees. Dew point means if this space temperature gets below the dew point of the air, it will condense, just like dew condenses on your grass or your car windshield or something like that. And if it condenses, it's much more likely that bad stuff is going to be growing in behind the walls and stuff like that. So the dew point always needs to be fairly low. Right now we're at 55, 54. That's really good. No problem there. So that's something easy that you can measure, that you can pick up a probe for temperature and humidity pretty much anywhere. If you want to dive into some deeper stuff, there's all kinds of tools that you can use. So right here I have a portable air quality monitor. There's several different manufacturers of these kind of things. I just happen to have one here. This one happens to nicely connect up to my phone app, which is nice because then I can save the data and take pictures of it and stuff like that. So this particular one is doing a couple different things for us. One, it is measuring temperature and humidity. Right now we're at 75 degrees and almost 50% humidity. So I'm measuring that kind of stuff. It's also measuring CO2, carbon dioxide. That is an indicator of, well, generally it's an indicator of how occupied the space is. The more people in a room or in a building, the more they're exhaling and the more CO2 they're adding to the room. If people are breathing and adding CO2 to the room, but I'm not bringing enough fresh air in to dilute down the body odors and the germs and stuff like that, then the CO2 level is going to be pretty high. But if we have a lot of people in here and I'm bringing a lot of fresh air in, the CO2 level will stay low because the outdoor CO2 level is pretty low. So right now I'm actually pretty low. It's like 400, which makes sense because we're in a giant room. There's only two of us in the room and we had the door open for a while. So outside air kind of came in, right? But if it starts getting higher, specifically you want to pay attention to it. If it starts getting above, usually we say 700 parts per million above the indoor levels, which are usually like 400, 450. So let's just say for a check figure, if you're above 1,200 parts per million of CO2 in a space, you're probably under-ventilating the space and you need to address that in your building. This guy's also measuring VOCs for us. In this case, it's T VOCs, which is total VOCs. So it's kind of a combined number. There's all kinds of individual VOCs, volatile organic compounds, but this is kind of measuring a total of them. So we want those to stay low as well. And as you can see in our case, it's red on our app, showing you that we're up above the minimum level it should be. So it's kind of high in here. Cleaning chemicals and stuff like that are usually culprits of that. Or building materials, glues, adhesives, stuff like that can be involved. So if the VOC levels are high, maybe more ventilation might be helpful. Maybe air quality improvement devices like air purification stuff, or ionizers or something like that may help break down those VOCs and make them less harmful in the space. The other two things that we're measuring on here that are of interest to us are particulate count. So we got PM 2.5 and PM 10. 2.5 means 2.5 microns, which is a really, really tiny dimension, and 10 is 10 microns. So the 10 measurement is saying how many big things are floating around in the air, and the 2.5 is saying how many small things are floating around. Right now we're pretty low on both of these, at 9 and 10, which are very low numbers, so we're doing really good on the particulate matter. But if you have spaces where there's things in the air, if there's any manufacturing connected to your office building, if you were like in a casino and they allowed smoking, for example, those kind of things would add particulates to the air and will need to be addressed. The last thing we have here is a particulate counter. So it's going to measure particulates as well. Let me get it turned back on here. So this guy's going to sample all different kinds of sizes. So if I saw an answer on here that I didn't like and I wanted to take a deeper dive on that, I can use a particulate counter. Now this is a more expensive tool. Not everybody would have this kind of thing, so you may not have this, but if you found something alarming on a basic tool like this, you may want to dive deeper to see what's going on here. So this guy right now, I haven't started him yet, so we'll go ahead and do that. You'll hear him running. He's going to take a little sample on here. I think my sampler is like 10 seconds, I think I have it set for. He's going to draw air into here. There's a little tiny fan you hear running, and he's going to come back and give us a little report on how many of each size thing we see. Not just the 2.5 and the 10 sizes, but even the smaller, tiny stuff. So we'll let him finish up here in a second. But right now, as we're looking at him, for the 0.3 size stuff, we're hovering around 3,800, and 0.5, 1,300, 1, we're at 300. So some of those small things, we have a decent amount of stuff, but it's not even close to the alarming level. If you look at this chart over here that we're showing you on the screen, you'll see what the safe levels are that are recommended. So we're way, way, way below those numbers. And even on here on our little bar graph, you know, green is good, yellow is alarming, and then red is obviously a big problem. So if any of those particulate counts get higher, you'll have to do something about that. The two major things that you would do would be improving the filtration in your HVAC equipment. That would obviously be one thing that would help. And the other thing you could do is you could use an ionizer to break compounds down. So if I had large things that were in the air that were a problem, like 2.5 and larger, I could break them down to smaller things and bust them up. And then they'd be less complex molecules and easier to deal with in that regard. I can also charge the air, which could then group them back together, like positively or negatively charge it. We can group them back together, and then I can catch them back in the filter again. So I'll break them apart so they're not dangerous things, let them regroup in safer things, and I can capture them in the filter when they're regrouped into larger organisms, or larger compounds, I should say. So that's another thing that we could do to measure it. The solutions to these things, if you have too high of VOCs, too high of CO2, too large of a quantity of particulate matter, or too high of humidity or dew point in the space, the solutions are all going to be different, right? If my dew point and humidity are high, I need to solve that by A, getting rid of infiltration into the building, and B, improving my HVAC system, maybe smaller equipment so it runs longer, more staging so it runs longer, so I can dehumidify more. If I'm having issues with particulate matter, I may need to add exhaust systems to exhaust things out, especially if there's manufacturing associated in my space. If my CO2 level is high, I need to bring more fresh air in because I have too many people relative to the amount of fresh air that I'm bringing in. If my VOCs are high, I may need to break down those chemicals and bring more ventilation air in. So we got different kinds of solutions in the HVAC industry that would solve each of those kind of problems. But right now we just want to give you an idea of what kind of things to look for, maybe give you some stuff that you can easily measure on your own to start off with. And then if you need to bring a pro in to measure more stuff, then you can do that. Hopefully that gets you started on the right direction with indoor air quality.